Okay, so explosions, objects that are together in separate and opposite directions or at different velocities. Two examples I've got there, they start off together and then explode moving away at separate velocities, away from each other. And then you can have them both moving together, but then as they separate, one has a lower velocity than the other. But momentum's always still conserved. Okay? So we need to say to ourselves here, okay, although momentum is always conserved, kinetic energy may not be conserved. In most cases, kinetic energy is not conserved for explosions. Okay? But I can imagine maybe it is conserved in this example. It's definitely not conserved in this one. It's got 0 to start with, and then it suddenly has velocity. That's definitely not conserved.
If it starts at 0 and it explodes, it's going to stop at 0, right?
Yeah, but you're just not about the collision itself. We're not. So the point is, imagine these are all done in space with no friction. The only reason they stop is because of friction. So that's, we're not taking friction into account. We're not taking any of these external forces into account. Okay? We're talking, imagine there's a frictional surface. No unbalanced force acting on these objects. Okay? Right, so the best thing we can do now is start looking at some examples of this and using that formula which we had, which was M1D1 equals M2D2. And people get confused. People get confused because they start not linking up the right objects with the right masses and velocities. It's not a difficult formula. It's just a case of just use the right one. Keep yourself organised. Okay? Make sure you're using the right mass, the right velocity for the right objects. And don't just mix your way through it. So I'm going to go through maybe an example like we did yesterday. I'm going to show you how to approach it so that you don't get yourself too mixed up. Try and keep it as simple as possible. Okay? Once you finish this, going through an example for these, we're going to do a thing called impulse. The past paper question I gave you for homework for next Wednesday, 2 of them are on the website today, on the website last night. One question is on the inclined plane, and the other one is on momentum with a small bit of impulse in it as well. So we'll have covered impulse by tomorrow. Do impulse tomorrow. So you'll be able to do pretty much the whole question as of tomorrow. Okay, only a little small bit at the end, which is impulse.
How about the second one, like if the second falls, you just use the same M1.
Always, because momentum is always conserved. Okay, so that's collisions, that's explosions. We've done collisions. Let's have a look at